Welcome to Making Awesome, presented by 3D Musketeers. My name is Grant. We have Tad with us today. Tad is the lead engineer at 3D Musketeers, and I'm the owner. And we are here to help you learn and help you get enthusiastic about making awesome. Today's subject, we're going to be talking about the illustrious differences between 3D printing and injection molding. So let's first talk about injection molding, then we'll get into 3D printing, and then we're going to talk about where there's a lot of crosstalk, because there's a lot of ways where you can 3D print injection molds. And if you're watching on audio, I'm sorry, but I'm actually holding up a 3D printed injection mold. Watching on audio, that one's good. That one's good, Grant. You're listening on audio. You're watching on video.
Got the picture.
And for those of you listening to us, if you want to see our faces that are absolutely built, designed, and manufactured for radio, you can go ahead and check us out at makingawesomepodcast.com or 3dmpodcast.com. Or you can go to the actual link, which is 3dmusketeers.com/podcast, but everyone spells 3D Musketeers wrong, so we're not even going to bother. Tad, why don't you start us off with a little bit about injection molding?
Absolutely. Well, first of all, thanks for having me.
Yeah, dude.
So injection molding is probably how the vast majority of plastic stuff that you encounter in your daily life is made. Unless it's like really big. Some things like, outdoor furniture or like barrels, that kind of stuff will be made with rotomolding. That's a whole nother can of worms that we won't get into. I could share my screen for just a moment.
And remember, we've got some listeners hopefully out there, so we're gonna paint a picture for you.
We will paint a picture with our words.
With our words.
Could you enable the screen sharing?
Oh man,
technology.
Jeez, this is friggin' amateur hour here. Friggin' amateur hour.
That's all right. Worst things have happened.
Oh yeah.
There we go. I want to share this screen. Good.
Very cool. I dig it. So
awesome.
Describe for our audio listeners out there what we're looking at.
Absolutely. So what we have here is an injection mold base with the mold attached. This is roughly 12 by 16 inch block of steel. Weighs
looks like it.
A ton. I would know because I once carried one across campus in my backpack, and that about broke my back.
I'm imagining you carrying a ton of steel across a college campus, just beefcaked out, and it's hilarious to me. Yeah. Sorry, but I've got a mental picture here of, Tad with a backpack, like one of those big backpacks, like, the kids that really haven't gotten it wear, maybe ones with wheels, right? But they're carrying it on their back, and it's just got a big freaking thing in it, and everyone's looking at him like, what is he carrying?
I wish I was just kind of sweating and wheezing.
My day.
Yeah.
Sorry, go ahead.
But yeah, what we have here is you'll see on one side you've got your cavity, and the other side you've got your the top of the mold.
So, and the differences between them are, your cavity is your open area, right? Like a cavity in your tooth is an open area that shouldn't be there. In this case, it absolutely should be there. So we have the female side and the male side. The male side of the mold is everything that isn't plastic, rubber, whatever the material is that you're shooting in. It has metal components in it to make certain that you don't get plastic or, the injected material where it shouldn't be.
Right. And for instance, in this case, it looks like what they're making is some kind of enclosure, like, electronics will come in a plastic like chassis. That's probably what this is. So you'll have certain features on the inside, little ribs and things where like a circuit board would get attached, and that's going to be on the male side. On the female side, you've got the exterior. That's your cavity,
Right.
and that'll make the outside of whatever plastic stuff you're making, whether it's an enclosure for electronics or like a plastic cup. That's going to be the exterior. And then in the corners of this mold, these two blocks of steel, you've got these big old pins, and that's what the two halves kind of glide on when they open and close to let the parts fall out once you've injected the plastic.
Okay.
And then on the male side, you'll notice in the middle there's a gap.
Yeah, there's a gap and there are some springs there.
Right, and that allows the various ejector pins that pop the part out to actuate. So,
I think we can actually see them. Looks like there's one toward the bottom, left, right, and top, right? And so for people out there audio only, they're basically these metal pins that are tapered to a rounded point, and they're coming out at maybe a 15-degree angle or so. And those are used to kind of boop the part out, right?
Just pop it off.
And if you've got an injection molded piece around you, and the likelihood is you probably do, you can find these ejector pin marks. They look like little circles that have a different texture. They might look a little bit different.
Yeah.
But those are ejector pins. You might even be able to find the mold line, because no matter how hard they try, you have to have a mold line, right? There's a seam.
Yeah, that's the edge where the two halves of the mold meet. And sometimes it's not going to be perfectly on center where you'd expect it. Sometimes they'll mess with it so that they can get it in a more aesthetically pleasing location. So what I brought here today, this is a part of a printer cartridge. This goes over the brand new printer cartridge and seals the little port where the ink comes out. You just pop it off and throw your cartridge in the printer. So I don't know if this will show, if you could see that, but you've got, oh yeah, there we go. You can see the little round spots where the ejector pins
they're a little bit shinier than the rest of it.
Exactly.
Is that because these pins are warmed and so they're actually melting a little bit of the plastic as they're pushing it?
That's possible, but it's probably not by design. You know, this is the backside of the part. They don't care so much. Care.
I mean, that part's literally designed to be thrown away.
Thrown away, which is sad. Actually,
let's not even talk about the environmental issues that surround that, where we use a consumable that is unreasonably expensive, and then
I know
it's made of plastic that is, of course, at least in most areas of the United States, not easily recyclable. Like where I live, so I live in Florida. 3D Musketeers is based in Tampa, Florida. Tad does not live in Florida, and
like
we're
opposite.
I live, we don't have recycling. There's no pickup for recycling. If you want to recycle, you have to take it to a recycling center, which is about 20 miles each way. And you know, that's tough. So sometimes we do it, especially when we have big print jobs, and we have all the spools that are made of ABS that are generally injection molded. We take those to get them recycled. Although I have been cheating lately. I've been putting them up on Facebook Marketplace for free and letting other people come and get them because they're great for Christmas lights and that kind of thing. Or excuse me,
that is good use for them.
Extension cords too, but they have to be really short ones. Sorry, go ahead.
I'm no, you're fine. The only other things I would note down for this is the surface finish on here is really interesting. For most of it, everything pretty much other than this backside where they don't care as much, and you can actually see, I think you can see the tool marks on the shiny side a little bit. That's where the mill that they use to make the mold cut its little teeth on there. The majority of this though has a kind of a matte, rough surface finish, and the way that they do that is when you're making a mold, you do electrical discharge machining, which is where they make an electrode, usually out of carbon or copper or something, that Or
it literally
graphite.
burns away the metal. I've actually
Right.
seen this in person.
Mm-hmm.
A good buddy of the shop, Mike over at Spectrum Custom Molds and Manufacturing, it's a local veteran-owned injection molding facility. They do EDM, which is not like Steve Aoki EDM, although I'm probably going to get roasted in the comments. It's the first person I could think of because Steve is actually a client. It is where it's a milled piece of like carbon or graphite, and you just put a crap load of amperage into it, and you're literally just burning away metal with
Right.
it. It
It's
is,
the same shape, and they just kind of usually it's in an oil bath,
yep,
and they'll just put it little by
it's
little into the
scary.
part.
It's scary
Yeah,
to watch it. And yeah, my first thought was, Mike, if I touch that, will it kill me? He
probably.
said, I don't know.
Let's not find
But
out.
if you want to touch it, I'm going to need you to sign a waiver. But there's also wire EDM, which I've heard of. Can you explain that a little bit? I don't know if
Wire.
that does too much in this area, but I know it can be used to cut molds down into smaller pieces if you need to do it that way.
I haven't heard of it being used for that, but I wouldn't be surprised. Wire EDM is basically the same thing. You're just using a wire to do that cutting. Where I've seen it used is when you need extremely small features that you can't make an electrode for. So instead, what they do is they drop a wire in there, like a very stiff wire, and they just little by little uh, get out that material with EDM. Just
Okay.
discharge it and get rid of that metal.
And so
So,
in the picture,
mhm,
we've got like this center rectangle, and then surrounding it are these trapezoids with a little bit of gaps in between them. It looks like those trapezoids can be moved. It looks like there's either some sort of a track, or
mhm,
and what I'm seeing, right, I guess the ejector pins in the middle of those two tracks.
mhm.
Is that where the plastic comes in on the mold? Remember, and I guess for anyone listening out there, my background is in injection molding. No, my background's in 3D printing. I actually have 2 business degrees from the lovely St. Leo University, but I've dedicated most of my life to 3D printing. My office has a bunch of 3D printers in it. Tad has a mechanical engineering degree, but
Mhm.
spent a lot of time and still spends a lot of time around injection molding. My experience with injection molding is owning a very, very tiny Morgan press. It was a 50-gram shot Morgan press that I bought from God knows where, China. And it showed up like 3 months later. I had forgotten about it. We were messing around with 3D printing injection molds, which is possible. It's
Mhm.
just not practical. Not with a Morgan press, at least. That thing was fun. It was a great way to get your hand burned. But it never opted to be a great business practice for us. It made a lot more sense to kind of go into a strategic alliance with people that know what they're doing. But so Tad, and I know it's tough to explain this to people that
Mhm.
aren't watching us. So if you're listening, whether it's Spotify, iTunes, whatever, and you're like, damn it, I really need to see this. We're actually going to upload the recording of this to YouTube, and in the description of the podcast on your favorite listening platform, we'll have a link that you can go to where you can view it right on our website, and you'll be able to ask us questions there. So don't fret. I know this is a little odd. We're trying our best. We're both new at this, so work with us.
Yeah. And I mean, it's better with pictures, but
Yeah.
we'll do our absolute best to describe it verbally. To answer your question, those are, if I'm looking at this right, those are probably to make features that you can't just mold straight, right? Because
Mm,
usually the simplest way to mold things is just straight in and out, because that's how
right.
the two mold halves move. But when you have things that you can't do at a just straight into the mold, you have what are called slides, and that's what it appears to be there. So those can move side to side. That way, when you're trying to release the part from the mold, you can pop them back out, and the part will come out. Otherwise, it would not be able to get free.
Right, right. And so I'm going to bring up an example on my screen here real
Hmm.
quick. You don't need to stop sharing, I don't think. So I have a 3D printed injection mold that I almost just
Hmm.
dropped, but it's okay. It's a really tiny thing. It's got alignment pins there. on the inside, it is
Mhm.
empty because this piece is missing. This
That's your core.
is my core. Okay. And so what this actually creates are these. These are silicone socks. They go around the heater block of a 3D printer.
Mhm.
And particularly, it is the 3D printer sitting directly behind me, up above me. It is the Lulzbot Taz 6. It uses a hexagon style hot end, which you can look that up. It's not really widely used much anymore. And because of that, things like silicone heater socks don't exist. So you have to design and manufacture your own. Thankfully, the community in the 3D printing industry is amazing. And I think that's really a big step forward in manufacturing, is that this community of 3D printers, it started around open source and giving the middle finger to big business, saying, hey, we can legitimately compete, and hey, we can legitimately help you grow your business.
Mhm.
Because of that, things like this, someone did that work. All we did is we went online to a repository, downloaded it, and made them. And that enables us to run our printers faster, hotter, and with considerably higher cooling. And we actually have I have handfuls of them sitting on my desk. But what Tad was talking about, where you have that undercut, this one does as well. So this
Mhm.
is the top of the mold. Oh, look, my camera actually autofocused to that. Well, that sucks. I might be out of focus for the rest of the meeting. I might have to come in and come out. But
We'll
that's what
cope.
it looks like on the part. So when they're together, it's hard to do it. I'm trying to put them together. They're actually
Mhm.
stuck. And because this is RTV, so it's room temperature vulcanizing rubber. If anyone didn't know what RTV stands for, it's room temperature vulcanizing. It fits on just like that. And so to
Mhm.
get it off, you just peel the silicone off, which is totally fine for this particular use case scenario, where they take like 8 hours to make because it has to vulcanize. That's totally fine to peel it off. But when you're talking hardcore production, you don't necessarily have that option. So
Mhm.
these slides are really useful. And if we look at, I'm going to bring up for the people watching us a commercially available silicone sock that is for a E3D Volcano. It has little clips on the top that are definitely made with a slide.
Mhm.
So there is a core, and that core likely has those cutouts so it can fit. And all this does is it protects the hot end. It keeps goo and crap from the 3D print sticking to your nozzle. It keeps things looking pretty. And of course, silicone is a phenomenal insulator, both electrically and thermally. So it
Mhm.
enables the 3D printer to run more efficiently. Every one of our FDM or FFF style 3D printers have it. And if you don't know what FDM or FFF are, I highly recommend that you check out our talk on what is 3D printing, unless you don't like my voice. And if you don't like my voice, why are you still here?
I was gonna
Anyways,
say the time to hit next is long past.
oh yeah, unless they're waiting for me to say something stupid. But
Yeah.
I mean, geez, that happened within the first couple of minutes when I talked about people watching audio only.
Right.
Anyways,
Um, on this part as well, you can see that there are these two little square holes.
yep.
Those would be made by slides as well, because those would come in through the side. Because
Okay.
otherwise, if they were stuck there, you'd never get this part out, because the two halves of the mold are here and here. So that's going to come out, and then you can open the mold and pop your part out.
It's just
So
cool.
I know.
It's cool to watch the machines because some of these machines, they're measured in tons, right?
Hmm.
So Spectrum has a 100-ton machine, and that's clamping force. So it is
Right.
pushing two pieces of metal together with 100 tons. Now, for people that can't fathom what 100 tons looks like, your average sedan weighs between 4,000 and 5,000 pounds. That's 2 to 2.5 tons.
So
This press is 100 tons.
that's a lot.
So you're looking at the better part of 50 sedans stacked on top of each other in a very, very small point,
Hmm.
applying a metric 100 tons or so of pressure. It's really, really cool. And that actually keeps the molds from leaking
Right, because
because
otherwise it'll shoot out the sides.
yes, and there are some great horror stories and pictures online of machines that have failed where the molds didn't line up perfectly. And, when you're injecting hot plastic into something that is that tight, or you're expecting it to be that tight, you can put a lot of force to it. These machines, they generally use Archimedes screws, and I think that's going to bring us into your next image that you have. But
Right.
it's just a big corkscrew where you have hot plastic and it's slowly forcing it in. And it's
Yeah.
going to do that with a fair bit of force too, because you want to fill up and make sure there's no air pockets, because that is kind of the issue. And I'm going to hold up to the screen one of ours where I didn't put enough material in it. This won't work. This is garbage. And
Yeah.
so for people audio only, again, it didn't fill all the way up to the top. So this was 7 or 8 hours down the drain. And yeah, that sucks. But we have enough stock that it's not really a big deal. And industries like 3D printing, where you're able to rapidly replicate things, it is always good to utilize the fact that you can do that. When people buy 3D printers that have 3D printed parts, we recommend the first thing you do is print another set of 3D printed parts. Because, yeah, we've had this happen. Our Taz, actually, its front idler pulley snapped. And we had other 3D printers, but, it's pretty cool for a machine to make its own replacement part. So we zip tied it and held it together with super glue and JB Weld so that it could run that print. And it did. And it's still, God, it's got to be 3 years later.
To the finish line.
It limped to the finish line. We could have done it on another 3D printer. But what fun is that? It's way more fun to look at the printer and say, no. You put yourself in this situation, you're going to get yourself out. You can do it. You're like the little engine that could. The little printer that could. Anyways, carry on here.
All right. So here we have, this is sort of a schematic view of how an injection mold machine works. You got your hopper full of little plastic pellets. They go into this heated barrel with the Archimedes screw, as you were saying. And this has heaters on the outside of it. So it heats that plastic until it melts. And the screw drives the plastic forward under pressure into the sprue hole there, which goes into the backside of the mold, your cavity side. And usually you have what is called a runner in the middle, which distributes that plastic from the sprue to the various parts. You'll have probably between 2 to 4 parts, depending on their size and the size of the mold. And then on the left-hand side, you've got the other side of the mold, the male side, which is being pressed into it by a big hydraulic piston. And that's your basic injection mold machine. And here my next image is what one looks like from the outside. So this one in particular runs about 25 grand.
And that's a 50-ton, I think, because it's HM-50. And
I would agree, yeah.
How do you, is that Himalaya? Is that what it's called? H-I-M...
Himalaya? I've never heard this brand, but...
Himalia.
It looks really similar to the injection molder that I've used.
And when you look at these things from the outside, they're completely unmenacing, right?
Oh yeah.
They just, it's got a little hopper at the top to hold molten plastic. There's a cover that, basically says, hey, put your hand in here, you're gonna lose it, and we're not gonna feel bad because play stupid games, win stupid prizes.
Yeah, it's just got that little slidey door that you close across it.
This is a machine that has been refined over the past few decades and has become something that you could walk by in a machine shop and not understand that if your head was inside of it, it would kill you instantly. And if your arm was inside of it,
you're losing that baby.
Yeah. In America, you'd be getting a lawyer.
Yeah.
And a very expensive hospital visit because insurance.
Yeah, so here in the middle, right below that door, you would just throw a bin and let this machine go. And I don't know, the cycling time would depend on how big your parts are.
Yep.
But say, every 10, 15 seconds, it'll shut. You hear a sound as the the hydraulic pressure increases, it would shoot that plastic, and then it would open up again, and your part would either drop or be ejected out, and the bin will just fill up over the course of a couple hours. And that is high volume manufacturing, which 3D printing is not.
It is not. And here's a great example. So you may or may not know, but as of recording this, we are in the middle of a worldwide pandemic. And one of the big things to come out of this is that hospitals were woefully underprepared when it came to PPE. And the 3D printing community was called upon because we can whip up manufacturing relatively instantly. And I'm going to show one of our face shields. So this is the frame for the face shield. It is the 3D, I forget the actual name, but it is one of the NIH approved designs. It's a 6-hole design. We can make 2 of these every hour per printer. See, the big issue with injection molding is you have to make that big slug of steel. And that's going to take a long time because you have to understand everything that goes into making a freaking face shield. All the draft angles, where the ejector pins have to be. Can you do it with just one sprue, or do you need more? How many pieces can you fit on a mold? Those are all time-consuming things. And it normally takes about a month from start to finish to produce an injection mold.
And 20 to 50 grand, depending.
Oh, yeah. Let's not even talk about the price.
Yeah.
There were over 1,000 designs for 3D printed face shields as soon as the market opened up for the need. Within 24 hours, there were over 1,000 designs, and the National Institute of Health, the NIH, started testing them. And Prusa Research, so yay Prusa, there are 4 of them behind me on the second shelf, not the 2 big ones up top. There are 4 Prusa Mark III S's behind me. We have quite a few more. We love our Prusa Mark III S's. Prusa kind of led the charge in doing face shields. They produced tens of thousands of them because they have the world's largest 3D printer bank of over 1,400 printers. So they're able to say, you know what, we're going to shut down production and we're going to make face shields. So in the month that it took Spectrum locally to get their tooling made, we are part of the Print the Curve Flat Facebook group. We'll give them a little bit of a shout out. We made 14,000 face shields in 1 month. 3D Musketeers shut down for 3 weeks. We made 1,500. And then we really only took larger orders. It didn't make a whole lot of sense for us to do 5 or 10 pieces when there's someone with 1 printer that could do it in a day. Because at the end of the day, they're still going to get it tomorrow. Spectrum is able to pump out 10,000 a day. A day. There's no way. And that's per machine, by the way, 10,000 per machine per day. If we ran 24 hours a day, 7 days a week per printer, we could do what? 45, 40,
something like that.
Technically 48. But let's be real, they're not all going to be perfect. So let's call it 45. I mean, that's orders of magnitude better than 3D printing. But there was that month where traditional manufacturing was caught with their pants down. Right? We as the United States relied and still do heavily on overseas manufacturing. And we took for granted that something like this would never happen. And it did. And of course, the trade wars that have been going on, while theoretically are good for the economy long term, really hurt us when pandemic came in. Yeah. Will there be benefits from it? Sure, maybe. But when March 2020, February 2020, January 2020, that trade war was one of the worst things that could have happened to the United States. And unfortunately, we haven't taken it as seriously as we probably should, but we're going to keep politics out of this one too much. But that's just a bit of an example of 3D printing versus injection molding, of an actual real world example that many of you listening will be able to at least understand and kind of get an idea of what that looks like. You know?
Right. And it just sort of speaks to the competing use cases for the 2 technologies, right?
Yep.
So with injection molding, you've got your high volume manufacturing where you want, tens of thousands of something. But what you got to put into that is, right, as you were saying, the time
Yep.
and the money, and there's a lead time to that you can't get around. Whereas with 3D printing, you've got the
It's all
agility to
just in time.
change. Yeah, exactly. You just get as many as you need, no more, no less. You can adjust your design on the fly, and the next one you make will be different.
Yep.
Whereas you couldn't usually do that with a injection mold once it's finalized. Um, because I mean, there is a little bit of flexibility in the beginning. Usually they'll do like one out of aluminum to test it out, which is much cheaper, obviously, than doing the steel. But there's still not that much flexibility.
Right, and that's a bit of a problem. And like Tad was saying, there is a certain point where your return on your investment does not make sense to do 3D printing. And at 3D Musketeers, we actually help you figure that out because, look, we love money, and if you want to give it to us, we're happy to take it from you. But you're likely running a business. You're an inventor. You're someone that matters. And if you want to throw money away, by all means, throw money away. But we don't want you to do that. That's not the goal. The goal is for you not to throw money away. So we'll work with you and make certain that you're not gonna. Let's say if you wanted to do 10,000 of something, I'm almost always going to tell you should look into injection molding. And you might decide that, hey, that upfront cost is really high because you're going to have that 18 to 20,000, if not more, upfront mold costs. And of course, we're talking about United States-based manufacturing. When we look at overseas manufacturing, your mold cost is going to go down considerably. But it's where they get you.
Still a chunk of change, though.
It is. We've seen them as low as $3,000 or $4,000, and what they do is they amortize it out by charging you more for the pieces.
Right.
So if your widget would cost $1 to manufacture here in the United States and you have a $20,000 mold, China might say, well, we'll charge you $4,000 for the mold, but it's going to be $1.05 for it. And you're going to say, well, I don't care about 5 cents.
But that's how they get their money over the long term.
But if you make 1 million pieces,
yeah, that adds up.
That adds up to a lot of dollary dues. And that's something to keep in mind. The other thing with injection molding, kind of the downside, is your MOQ, your minimum order quantity. With 3D printing, yeah, we're not huge fans of onesie, twosie stuff anymore because, there's not a ton of money in onesie, twosie.
Yeah.
And yes, it is a lot of time. But we understand that people need to prototype. But if you're looking, let's say if your order schedule's 100 a month, that's no problem, generally speaking, for 3D printing. We have a client right now that orders between 50 and 100 pieces a month. He has a just-in-time inventory system, so he keeps 12 or so sets in stock. When he reaches 6, he goes ahead and reorders another 12. And that way, his outlay of cash is not all that great. Yes, he's paying more for those parts than they would cost via injection molding, but he doesn't have to store 100 or 10,000 pieces.
Right.
You need a warehouse to do that, or a storage unit where they're not really concerned about what you're putting in there. And that's an added cost, of course, along with that upfront expense of all those pieces. And dude, if something happens and your idea becomes non-sellable, you're still on the hook for that inventory. With 3D printing, you say, hey, 3DM, yeah, we've had a problem. Go ahead and stop production. And that's it. It's over. You're done.
Right.
You owe us nothing more.
So exactly. Some products are niche like that. And there just isn't there is just not the demand to justify that much inventory on hand in the first place.
Right.
Do you think we could talk about we had a gentleman a while back who made an accessory for buses because he was a bus driver.
We can be very vague in that one, but yes.
Right. And
he came to us through Dontecia Seymour.
Right.
We'll shout her out because we like her. Dontecia is she's an inventor here locally in Florida who built a kind of a masterclass around inventing. So check her out if you're interested in learning more about inventing, or just hit us up and we'll get you in contact with her. Sorry, just wanted to give her a little shout out because she's a big fan of us and we're a big fan of her.
She brings us a lot of business.
She does. But go ahead, talking
yeah,
about a part for a bus.
right. And this gentleman was a bus driver, and he noticed this problem. And a lot of the other bus drivers in his school district were like, "Oh, I'd like that. That would make my job a lot easier."
It was an
And
ergonomic improvement.
right. And
Something that takes 30 to 40 pounds of force to do. He designed a product that took it down to less than 5. And, you know, look, when was the last time you guys saw a bus driver in their 20s, right? Let's be frank.
right.
A lot of bus drivers are, knocking on retirement's door, and they're doing it because they're bored. They need a job. They like kids and they just want to see smiling faces. There are plenty of reasons, but they've got arthritis. Your joints aren't what they used to. Hell, man, I turned 30 and I had a back injury. And I'm like, dude, I've been here. And as soon as I hit 30, I just fell off a cliff. So you can imagine what you're like when you're 60, 70 years old. And this product was designed to fix one of the major flaws in these larger vehicles. So, Tad, go ahead and continue.
Oh, absolutely. Well, he whipped up his prototype in his garage, and he's like, well, I'd love to make this in, not the tens of thousands, but, a couple hundred, a couple thousand, because locally it would help a lot of people.
Yep.
So 3D printing is the exact kind of case you want for that, because you can't justify the MOQ, the minimum order quantity, to invest in an injection mold and make 20,000 of them.
And not this guy either, right? He's not your Elon Musk, where he's going to say, yeah, no, here's 20 grand. I don't give a damn. Get it done.
Right.
This is a guy that put time into thinking about a problem. He's a mechanic. He works on these buses, so he hears, right? Mechanics have all the dirt. You want to find out what your neighbor's doing, find their mechanic. They're going to know. He heard these complaints and he said, I got to do something about this because there's got to be a better way. Desperation breeds innovation. And this is one of those cases where he solved a legitimate problem. And, we haven't heard from him in a while. And I hope that he's on a path of success, because I believe, and I think we both agreed, that his product is a gem of a product that
genuinely helpful to people.
Yeah. And could be an awesome royalty deal, right? Everyone knows Shark Tank, right? He wasn't big on this, I just want 100 grand and I'm going to go retire. He doesn't want to stop his job. He loves what he does. But a little extra money at the end of the month certainly ain't going to hurt nobody. So
right.
He wants to see people get help. And, I can't think of a better example of the American dream, right? Just a blue collar, right? Blue collars, people that work with their hands. Okay. When I think white collar, I think of the show, and it always ruins it for me. It's a great show. I'm sorry. But, just a real, like, traditional blue collar, hardworking American, lives in Georgia, right? And just, he has like this story of someone that just, he honestly wasn't even in it for the money, man. And that was the hardest part working with him, is that he's like, look, I don't want any money. I want to get it done. I want to help people. And I'm getting goosebumps just thinking about it, man. Look, we know who you are. You know who you are. If you're listening to this, please reach out to us, man. We would love to hear what's going on. And if Tad or I can remember, maybe we'll shoot you a follow-up email this coming week to see what's going on. But and there are plenty of examples of this. Unfortunately, we find all too often in the inventing world that people are trying to solve a problem that isn't meaningful. Just because it upsets you does not, under any circumstances, mean that it upsets somebody else enough they're going to pay for it. Okay? There have been so many ideas recently, and they're all surrounding COVID, right? Where they're trying to solve a problem that, if it really needed to be solved, it would have been done by now. And we're not saying that there's no profit in it, but it's not $1 billion idea. Maybe it's a $10,000
Mhm.
idea. And if that's all you're going for, great. Hey, but it does suck, right? There's so many people right now that have been furloughed, have been laid off. I mean, was MGM Grand just laid off 18,000 employees that were
Yeah.
furloughed? Dude, I mean, a friend of mine worked at the local Hard Rock casino. She was furloughed and laid off. Now she's an Amazon delivery driver. She's can't be a lick over 21. I mean, it went from being I think she was a dealer. I really don't
Mhm.
know what she did at the casino. I'm not one to visit casinos. And now to be an Amazon delivery driver because she's got bills to pay. And Amazon's one of the few places that are still hiring right now. This is a tough time for all small businesses. Hell, I mean, 3D Musketeers has seen some adversity. We were actually written up in Big Stories, Small Businesses, and it was published on Medium. So we'll include that down below as well. So you guys can read a little bit about what happened. I mean, we saw a 90% reduction in our expected revenue this year because of COVID-19. Because
Yeah.
what's the first thing to go when money gets tight?
Discretionary spending.
Correct. And
Mhm.
while it's really, really cool to have models of stuff in your office, it's not needed. And that kind of sucked. But we're improvising, adapting, and overcoming, and we're hoping to finish this year strong. I don't know. It sucks. As a business owner, it sucks. I'm not going to lie about it. It sucks. But we're glad that in this industry, there's a lot of people out there helping each other. And, we started this podcast to help other people because we understand that, you want to make money. You
Mhm.
want, if you're listening to this, you might say, I hate my boss. I hate my job. I want to give my 2 weeks or give them the middle finger and walk out. But you probably can't do that because of bills, because of, kids, wife, husband, both. Um, those are expenses. And yeah, it's tough at home. There's times out there right now, but we believe that you have the potential to make awesome. And so this is something that we don't publicize, although not yet. We might soon. But if you've gotten this far, you're like, damn it, Grant, damn it, Tad, I want to make awesome too. Call us, email us. All that information is going to be in the description. We're here to help you. We will do a consultation with you. It might just be me, but if we're lucky, we can get Tad in here.
Mhm.
Absolutely free. It costs you nothing to talk to us. And whether you want to talk about injection molding, you want to talk about 3D printing, you want to talk about laser cutting, CNC milling, I don't know, cats, uh, we're here. We understand these times are tough for everyone, and we want to help you because we believe that a rising tide raises all ships. God, screwing up a great proverb, man.
It is good.
Jeez. By the way, I am unscripted. I don't know if Tad ever got his outline done. I didn't
Oh
even
yeah, I
start it.
forgot about that. We'll do it live.
Yeah, F it, we're doing it live. So I see you have another photo up there. What's the other photo that you have for our viewers? Or is that
Um,
unrelated?
nope, that's it.
Okay.
That's just this is just the same model. I mean, the same mold I was showing before.
No. There's a third tab that you have open. The
Oh
JS.
no, that was
Oh, the
just the
JS50. That's the thingy.
exterior.
Yep.
Yeah.
All right. So then I guess let's talk about 3D printing. You might have heard of
Mhm.
it. You might know the company Defense Distributed. And if I probably said Liberator, you might know what I'm talking about. We're talking about 3D printing. A lot of you know it because of the 3D printed gun. You know Cody Wilson. You don't know his name, but you probably know his company Defense Distributed. Hell, the only time we've been on the news for 3D Musketeers is to talk about the 3D printed gun. And I will never forget the look on the reporter's face when I torpedoed her story on ghost guns and explained how the system actually works in Florida and how stupid a plastic gun actually is. Now, a polymer gun made by a manufacturer in an injection mold, see, we're circling back here, is a lot stronger than something that is made by a computer-controlled hot glue gun, which is what these things were made by. So let's talk 3D printing. You have a few different types of manufacturing. We're going to talk about two specifically. We have subtractive and additive manufacturing. Subtractive is, if you're watching us, what you see on your screen right now, that image that Tad has up of that injection mold, that is made with subtractive manufacturing. There was a block of steel. They turned it into a smaller block of steel with stuff on it. That is subtractive. You have chips. You have leftover garbly gook. With 3D printing, you start off with a raw material. With FDM or FFF 3D printing, fused deposition modeling, fused filament fabrication, the same thing. It's normally a roll of filament. This material is melted at very hot temperatures. Actually, we all joke that one of the hazing processes to being a true 3D printer is getting burned on a hot end. Yeah, because like currently there is our Fusion 3 F410 running. I do have the lid propped because it gets a little too toasty in there. But that thing's running at 250 degrees centigrade, and it will be running at 270 degrees centigrade when it starts to speed up. And so maybe at some point through this, you'll actually see it sped up. But anyways, this 3D printing is all about dealing with making something that you either need in really, really low production, or you need it, how can I say it?
You need like prototyping or design validation, or you don't want to make that capital outlay.
Exactly. Something that you're able to manufacture on a small scale, and maybe it's something to test, right? It doesn't have to be crazy.
Right, it doesn't have to be perfect.
Right. It's literally a test piece, and we've done fancy stuff. I'm trying to see if I have something that I can show off. I do. And it's period correct, if you will. It is the Montana mask. This was the first 3D printed mask to ever be approved by the CDC and the FDA for emergency use. Fits over the face. You put a little filter in there. Quite frankly, my favorite adaptation of this is the one that makes it look like, is it Scorpion from Mortal Kombat?
Yes.
Although the Immortan Joe ones of this are absolutely hilarious. I will never wear one of these because it is hard plastic. It is not very flexible. And honestly, while they work, no, you're going to get a rash.
Yeah.
Because 3D printing is not body safe. And people say, oh, I can make cookie cutters. Yeah, you can. All right, I'm not going to lie to you. You can make a cookie cutter. Why? Because it goes in the damn oven. And whatever crap is on it is going to get baked off. And if you put a piece of cling wrap between the cookie cutter and the cookie dough, you're protecting it anyways. Anyways, these machines, they're, okay, it just sped up. I don't know. So I'm looking at it. It's now heating up from 250 to 270.
Yeah.
But yeah, you can see it a little bit. I don't want to move the camera because I'll never be able to get it back in the same place. But
and focused.
It's great for these one-off parts. It's actually making a set of 12 parts for a local company that they're doing to test. It's a feeder mechanism for bottles. And this is all a test. They want to mill this, and this is as far as we're concerned, it's a relatively expensive job. When I gave him the price, he's like, oh my God, yes, do it.
Yeah.
I said, okay. Anytime we give a quote over $2,000 and nobody blinks an eye and they just tell us to do it, I'll get their money, right? And then we ask them, okay, you didn't hesitate at all. Why didn't you hesitate? And I asked this to the client. He said, because this is a $40,000 mold. I don't care if it's 10% of that. for 3D printing. I said, so wait, I could have charged you more? He's like, yeah, you probably could have.
But that's the thing. It's worth it to
We don't care.
spend that money to
Mhm.
find out if your product is going to work the way you want it to, be sized and shaped
Yep.
the way you want it to. That way you can absolutely be 100% happy with it. And then you can spend the money on the final product.
And here's a really cool thing. This is not the first one that we've done for them. We did a different revision that they were sold on. They like, we know we did all of our testing. It should be fine. We gave him the 3D printed part. He said it worked for about 10 seconds and then it basically exploded.
Mm-hmm.
Because these are vibratory feeders. This whole part is vibrating at crazy amounts. And he said, I'm so glad we did this test because had we spent the money and got this milled out of Delrin, it would have likely also broken. Delrin has similar properties to the material that we're making this out of, which is PETG. Delrin is a self-lubricating plastic, which makes it phenomenal for these types of feeders. But it's also quite brittle.
Mm-hmm.
It doesn't flex a lot before it breaks. And when you're basically buzzing the crap out of it, you're gonna have problems. And so this customer understands the use case of something like this. And don't get me wrong, I would love nothing more than to have 15 machines doing $2,000 parts that we can do every single week. But it's not realistic for where we're at right now as a company. We do a lot of small stuff. Actually, oh, it's blocked. The first resin printer. And so I'm pointing off to my right. There are, they look kind of like cylinders in the video, but they're just tall boxes that are alternating colors between red and yellow because I can. And they are resin printers. So we have a second technology here called high detail resin. Its technical term is SLA, stereolithography additive manufacturing. Why it's not SLAM, I don't know. Feel like that's just a lot cooler. Call it SLAM. What are you doing? I'm slamming. Maybe that's why they chose not to do it. Don't ask me. I wasn't born when this technology was invented. For 3D printing's been around since 1984. I was born in 1990. Oops, gave away my age. Lady never tells her age, though. Well, Grant, that's probably because, well, you haven't been a lady since college, and we're not going to talk about it. No, I'm joking. SLA is great. It's an awesome process, but it's very, very, very high detail. You will get parts off of those machines that are injection mold quality. Like literally the parts, and I wish I could show them, they're rings because they go directly into casting. They come out of the printer. We rip them off their support. I give them to the client. She does magic, really, because I don't understand this process, but it involves wax sprues and basically surrounding it with ceramic plaster, and then you heat the ever-loving bejesus out of it, and then you pour in molten metal and pray, if that's your thing, and hope for the best.
Good old lost wax.
Lost wax casting, exactly. Actually, the yellow printer all the way at the end, oh, it's not, you can't see it in the video, dang it, actually has wax resin in it, and for the life of me, I cannot get it to print. I have had 4 failed prints, and the customer's like, can I see photos of what it looks like? I just send her like these flat little plates, because that's what happens if they don't stick. I'm like, yeah, I don't have an answer for you, because this stuff sucks.
That would remove a step from the process, wouldn't it? She could go directly to wax.
My hope is that she can find a way to do the burnout schedule with just the normal resin. One, it's like 1/4 the price. And 2, it's way easier because we've figured it out already. Layer times on normal resin is between 7 and 15 seconds, with your bottom layers being somewhere in the minute range. This thing is a 2-minute bottom layer. You need 10 of those. And then your individual layers are between 40 and 60 seconds. So huge amounts of time. I started the rings in the normal resin when the jewelry wax resin was 25% of the way through, and it finished well before the wax prints finished. But if you're looking for extremely high detail stuff, we recommend it. Let's say you're doing very, very, small parts. You can use this as an analog for a 3D print, for an injection molded part.
Yeah.
So when you're going up to investors or potential business partners, shout out to crowdspark.org, another company that I'm involved in. You're able to say, look, this is exactly what it's going to look like.
Because you'll have the same surface finish. Whereas
Right.
with, say, FDM printing, you will
Yeah,
get, even at the best quality that you can do, Grant, which is very good. I was going to say, I just bought a Prusa myself. And
You did.
Grant
I'm so happy.
I'm getting on the gravy train. Grant printed me an alternate set of parts for it, and I got to say the quality is fantastic. But there is still that little bit of stair stepping. So for people who don't like that, or
Yep.
if it's not suitable for the surface finish you're trying to achieve, resin is another option.
We're gonna break the rules of podcasting. I'm gonna move my pop filter back. We're gonna do a little ASMR of scratching across the 3D print.
It's your fingernails sliding across the little grooves.
Sliding across the grooves. And that is actually why 3D printing, got to move this back without hitting the microphone. Careful, Patrick. Demonetized for a SpongeBob reference. Oof. But, that's something you can't get away from. Those are printed like on the edge of glory. Oh no, on the edge of what the 3D printer is capable of. So the quality is not great, and that's done because we were more concerned about speed. I don't care if the face mask looks like crap. Does it work? That's all that mattered. When we got the call of we need help, we said how. That's all we said.
As long as it's functional, that's all that matters.
Right. That's all we cared about. Because of those micro cracks and fissures between layers, you can have issues with parts not being able to be sanitized. And that was really my big concern with these 3D printed masks, and actually why we never went into production of them. We tried them out. I said, it's a great idea in theory. And the Montana Mask Company, the guys that put all the effort into this, they use special filament that's got copper in it and it's got other metals in it that sanitize naturally, like brass, bronze, copper. Those are all metals.
Those metal ions will disrupt the cell walls of bacteria and the capsules of viruses.
Yep. It's like when you see, like traditions where they, like at St. Leo, the tradition is to rub the knee of the professor standing by us. It's a statue standing in a
bronze statue.
It's the tradition. When I lived at Rollins College, so I've been born and raised on colleges. Long story of my life. We're not getting into it. Rollins College had a Benjamin Franklin, and his hand was out like this. And so the thing was, you always went and shook his hand. These are bronze, and so the areas that are always touched are not patinaed like the rest of it. But because it's bronze, it's clean. It's actually clean, even though people are touching it all the time. Exactly. Which is so cool. That's like a topic that's way outside of the stuff that we need to talk about, but something I'd love to get involved in. It's just really cool to talk about it. And as a guy that loves clocks, I wish I had my Ansonia crystal.
Oh, that's a rabbit hole.
Huh?
That is a rabbit hole to get down.
Oh God, yes. Yeah, we could go over to the clock shop and, boy, have a time, if you will.
There's an idea for an episode, though.
Oh God. Oh man, that'd be a tough one. That'd be fun though. You're right. I have to bring this whole setup over there. Jeez. Anyways, it's 3D printing serves its purposes, and I'm going to hold up a hot end because I happen to have one here. So if you're audio only, sorry, I'll try to describe it.
We'll describe it.
So
it's like a hot glue gun, basically.
It is. These are computer-controlled hot glue guns. And so we have, and because this one's a copper variant, you can see different colors. We have a heat sink, which is a cylinder with a bunch of slits cut in it, basically. So it's lots of surface area. You have a metal heat break, which goes between the heat block, which is a big chunk of aluminum or copper, and the heat sink. And the idea is you want to transfer as little heat as possible, but you still need to have mechanical connection. On the bottom side of the heat block is the nozzle. The nozzle is the business end of the 3D printer. They range in sizes all the way down to like 0.2 millimeter. The largest one that we have that we use is 1.2 millimeter, which is capable of doing a 1 millimeter thick layer. Normally, 3D printers are doing 0.2 millimeter thick layers. It's 200 microns. For a size reference, the average human hair is 100 microns thick. A piece of paper is 100 microns thick. So put that into your head, right? So 10 sheets of paper stacked together is roughly a millimeter. That's how big of a layer this printer can do. So you're looking at 5 layers at once. It's nutter butters to see this happen. It's comical when I watch printers like the Fusion 3 lay down 0.2 millimeter layers in really, really high res. We have nozzles for that we can lay down 0.6, 0.5 millimeter layers, where you get a lot of speed, but you trade off quality.
Precision, yeah.
Precision, which is a much better term. Thank you. Precision for speed. When you're dealing with smaller layers, it's a lot easier to deal with. And so there are a few different variants of 3D printers. You have your standard, you know what, I'm not even gonna get into it. I'm gonna have a deep dive on 3D printing, and we'll talk about the different types of hot ends, what they mean, why they exist, and we'll have some on display here that if you are watching on video, you can see as well. But really the bulk of 3D printing is if you need it relatively quickly, if you don't have a ton of money to spend,
right,
and you don't need more than, let's say, at most a couple thousand.
And if you need to be able to pivot quickly,
yes,
and alter your design without spending all the money to redo everything,
3D printing is the way to go for those kind of things. We're working on an inflatable project for a client. We can't 3D print that. There's no way that we can 3D print that, and that's okay. We're not 3D printing is not always the answer, and I think a lot of people call us with a problem, and they've looked like we had a guy literally the other day call us about a tail light for his car. Now, in his defense, it was a 1988 Honda Civic. It's an old car, and I'm like, they can't be that expensive. They're actually pretty expensive. But I'm not going to 3D print anything that needs to be DOT regulated, so we're not going to get into that.
Well, and I don't think you could do FDM to make like an optically clear lens. That's going to be a nightmare. It wouldn't be
optically clear. You would make it cloudy, so like a clear PET, and then you'd put a light dusting of like a candy apple red, or you put a red bulb in it. But the dude bought the car for $300.
There you go.
And I said, sir, with all due respect, and I'm not here to tell you what to do with your money. Anytime that we have customers that we know 3D printing is not the right option, I always say, I'm not here to tell you how to spend your money. If you want to spend it with us, please do. But I said, look, you bought the car for $300. Put some packing tape over it and call it a day. Okay, it's a $300 car. I wouldn't be concerned about it. I really wouldn't. And it was a 5-speed, and the clutch was still in good shape. I'm like, that car's worth more in scrap. It had 380,000 miles on it. I mean, for an 88, that's not bad. It's back with the old VTEX. But, there are cases where 3D printing doesn't make sense. Don't 3D print guns. Just don't do it. One, okay, let's get into this a little bit. It is legal. It is 100% legal to 3D print your own firearm. If it never leaves your home. It never goes in the hands of anybody other than you. It should be treated as making your own firearm. So like if I was to use my own CNC machine to mill out my own firearm, it is the same principle. It does not leave your home. It can legally, but it takes one ignorant police officer, whether you're right or not, is not going to keep you from getting arrested or worse.
In most jurisdictions, actually the police are not strictly required to know every aspect of the law, so you have that working against you.
Correct. And you can be right up and down the road, red in the face. It doesn't matter. Is it interesting? I guess. But if you're a gun guy, the Liberator is the size of a judge. And a judge fires a .44 Magnum or .410 shotgun shell. This fires a .380 auto, a really tiny bullet. A 44 Magnum is 0.44 inches in diameter. A 380 auto is 0.38 inches in diameter. But if you look them up, there is a very big difference in the size of the bullets.
Well, the Liberator is single use, right?
It is single use. Everything clips together, and you do have to put a slug of metal into it.
Right.
If you don't put the slug of metal into it, you are violating the Undetectable Firearms Act of 1986, and you will go to federal prison. This is not, I'll just go to, state jail for a couple days, see my homies from the hood, and then come out. No, you're going to federal prison, where now you've lost your rights. You can't vote. You can't own firearms. You can't even own sharp kitchen knives without a parole officer up your ass so much.
And as a mechanical engineer, luckily, as a mechanical engineer, let me just be clear. Don't do this. Don't make one, because is not, a precision piece of equipment.
It's
and
stupid.
Your likelihood of having it explode in your face when you fire it is extremely high.
I don't know if you've watched the show How to Sell Drugs Online Fast. It's on Netflix. There's actually a whole scene where they try to defend themselves with a Liberator, and the gentleman that they're trying to defend from says, "What is this, a plastic gun?" Because they tried to shoot it and it didn't work. He puts it up to his head. He pulls the trigger. It kills him, but it also explodes.
Right.
And that could not be a better representation of those things.
Yeah.
They are death traps.
They're probably more dangerous to you than they are to anyone that you would use it against. And good luck hitting the broadside of a barn with it. It's probably like a Revolutionary era musket.
If you're lucky. But see, muskets had ball ammunition that went straight. Okay? Yeah. The circular ball meant that it would travel straight. Modern bullets are cylinder that have a rounded nose on them, because in barrels they have rifling that cause the bullet to twist.
Imparts a spin, yeah.
Right, and that spin is what makes them incredibly accurate. Even little tiny 22 long rifle are still incredibly powerful. This, you're firing a regular bullet, which is designed to spin out of a gun that doesn't spin it.
If it leaves the gun at all.
Yeah, that's true. It probably will. It might not go very far.
Yeah.
But, look, don't be stupid. Just don't do it.
Play stupid games, win stupid prizes.
We do recommend, if you want to get into 3D printing at home, that you call us first. Here's the deal.
We can advise you.
Here's the deal. We sell one brand of 3D printer. That's mainly because Prusa doesn't have resellers yet, but if they did, I'd get on that list. It is the Fusion 3 F410. It is 90 pounds of American-made awesome. They are roughly $4,800, about $5,000 with shipping, everything included. The average home consumer is not buying one of those because that's not what they're for. They're for people like 3D Musketeers and larger businesses that want to set and forget. If you noticed, we started to print basically right before we started the recording. And other than looking back at it to make sure it's not making weird noises beyond the noises I expect, and to make sure that temperatures are stable, that everything's happy, I don't touch it. But we recognize that the average person isn't going to spend $5,000. They might not even want to spend $1,000. This Prusa's run about $1,000, $800 if you want the kit.
Mm-hmm.
And so if you want to buy a 3D printer, whether it's for you, for a kid, for a friend, for a relative, call us first. We are not motivated to sell you a printer by money. We are motivated to sell you a printer by user experience. Mm-hmm. We want you to not come to us and say, this piece of junk, this industry sucks and you suck, because it's happened. We've had people blame us because they bought bottom of the barrel printers that caught fire, because that's somehow my fault. Spoiler alert, it's not.
Buyer beware.
Yeah, buyer beware. If something is less than $200, ask yourself why.
Yeah.
Ask yourself how. And what corners are they cutting that generally result in your safety? We talked about it in the 3D printing intro, but ANET is a company responsible for 7 major house fires in the year 2019. I haven't been following this year just because COVID.
Right.
3D
bigger fires to worry about.
Yeah. That's 7 major house fires that resulted in partial or total loss of the home from a $200 toy. Spend good money. Because if you don't spend good money, you're going to trade your time for money.
Yeah.
So we recommend, if you're interested in 3D printing, get a print from us. Go to Thingiverse, go to GrabCAD, go to Yegi, go to My Mini Factory, go to Thangs, which is a new one, THANGS, brand new from the company Fizna. Crazy name. I don't know if they had to pay for that, because that sounds like that'd be one of those URLs that has been taken for a long time. But it's thangs.com. It just makes you think of the 70s that I wasn't obviously alive for. But when music was good, I don't care if you like modern music, you're wrong. Earth, Wind, and Fire for life. Oh, and there we just lost our entire under 30 demographic. Did you see that? Did you feel that, Tad? I
felt a disturbance in the force.
It would have been funny if you still had your Tatooine virtual background up.
I wish that wasn't such a distraction.
Because then I would have made the Tatooine joke, and that would have been terrible. See, I even found a way to work it in. I told you I was going to do it.
I fell for the trap.
Yes, it's a trap.
It's a trap.
Seriously,
guys. Good at that, right?
It's a little too good. If you've made it this far, thank you guys so much for listening. I feel like we're just ranting at this point, and that's okay.
Yeah.
Look, if you got questions, I don't care if you think it's stupid. Give us a call, shoot us an email. Everything's going to be in the description. We're here. We're 3D Musketeers. This is Making Awesome. I'm Grant. That's Tad. We hope you have a wonderful day. Night.
Thank you for joining us.
Afternoon, evening. Hey, we don't know when you're listening. It's 5 o'clock somewhere. Don't drink and drive. Stay safe. Stay healthy. And that's the news.
Thanks for joining us.
Have a good one, guys. Take care.